Today we are going to understand theory behind face detection. In this video, I'm going to give you insights on how we will approach this problem throughout this video series. So let's get to it. We are going to understand using this image as our example. So the main idea is to divide this image using grids. For understanding purpose, let's use a grid of 3 by 5. Now each block will be responsible for identifying and localizing a face. Now the question arises, what happens if a face extends to multiple blocks? For example, this face extends to these two blocks. Answer to this is very simple. If a block contains center of a face, it will be responsible for that face. So this block will be responsible for this face. Similarly, this block will be responsible for this face, and this block will be responsible for this face. So each block will give us an output that will look something like this. Now let's understand what this means. Here we can see classification and localization happening. PC stands for probability of a face. If this value is 1, that means there is a face in this block, and then we will check other outputs. If this value is 0, that means there is no face. So we do not need to check these values as there is no face. The rest of these values tells us the coordinates and width and height of a bounding box. So in the end, our main output will look something like this, where each block of the face represent a block from the image. So this block represent this block here in our output, and similarly this block in our image represent this block in our output, and so on. So now let's understand how we will get this output from an image. So we have an image of some width and height. So what we do is that we pass it through a convolutional neural network so that it gives us required output that we need. And so let's see how we can use convolutional layers to get the required output from the image. So let's say we have an image of 18 by 22 and it's an RGB image. So now we can pass it through a convolutional layer of 5 by 5 and which has 5 kernels. So we will get an output of 14 by 18 by 5. Now if we apply max pooling to it, we will get the output as 7:9:5. And on applying convolutional layer again, we will get the output as 3:5:5. So we have divided this image of 18:22 into a grid of 3:5. And this is how we can use convolutional layers to get the required output. In the future videos, I will be telling you how we can code this using Python and Keras. I hope that you learned something, and I will see you soon.